Thank you, beta. So, good morning once again.
Good morning, ma'am.
So, we can start with it. Start reading, beta.
Earthing is proven in buildings to protect us from electrical shocks due to any leakage of electrical current.
That means if at all there's any leakage of electrical current in any sort of building, okay? So, there's a mechanism of earthing. That means if at all there's any leakage, it just goes straight to the earth and there's no destruction of either the building or to any lives. Is it clear? So, people are not electrocuted, building is not on fire. You understand? So why? Because all the electricity which were leaking earlier is been taken or channelized to the earth, and the earth absorb all the leakage of currents. Hope you understood. So that is called as earthing. What it is called, beta? Earthing. You
Earthing.
understood now? So lives are saved and the building is saved. Now we'll see how the charges are transferred from one body to another body. Please begin. Please start reading. Hello. Girls, start reading better. Girls, can you hear
Yes,
me?
ma'am.
Yeah,
Yes, ma'am.
start reading. Start reading.
Transfer of charge. When a charged body is brought in contact with an uncharged body, charges pass from the charged body to the uncharged body.
That we have
This
already seen.
method,
That we have already seen static charges, right? We rub
yes,
the scale with a piece of cloth and then we bring it to pieces of papers. The comb will or the scale will start attracting those pieces of paper. That is momentarily. There's no flow of electricity or there's no flow of electric current, but there's flow of ions. You understand? Hello, there's a flow of charges. Do you understand or not? So it's just for momentarily. After some time, it will lose the electricity. Got it? So that's why it is called as static. Just for some time, it remains, and after some time, it loses the effect. Second,
when a charged body is brought in contact with an
that is done.
uncharged body.
But you have already done it. Go for
Yeah,
the second one.
okay, ma'am. This method of charging a body is called charging by contact or conduction.
See, that body, the scale is the body, right? That body
Yes,
was not charged earlier. So when it came in contact with a piece of cloth, when we were rubbing with a piece of cloth, that time it got charged by contact, isn't it? So that time
yes,
the conduction of the charge took place. Otherwise, it was uncharged. You agree or not?
yes.
Okay. Now the third,
If a body is charged by contact, it gets the same charge at the charged body.
so the charged body, for example, when it comes in contact with another body, the same charge will be delivered. You understood? The same charge will be transferred. Okay? Fine.
We
Now,
can
which is the
observe the
device? Yeah,
transfer of charge by using an electroscope. If a charged plastic rod is brought in contact with an electroscope, the charges are transferred to the metal strips and they repel each other.
fine. Now, this is the device which is called as electroscope. This is electroscope. Got it? This is
Yes.
electroscope. Now, we got a charged refill. You can see this? This is the charged. I have rubbed it with a piece of paper and I brought it near the mouth of the electroscope. What happens? If it is plus, for example, the plus will go to this metal, this will travel down metal, you getting it? And this will also become plus and this will also become plus. So what will happen? These will ripple. See, you can see over here. They will go away from each other. What do you say? Because Like charges always repel each other. You agree? Both are positive. So they will go away from each other. So they will repel each other. Any problem?
No, ma'am.
So this is because,
Both the metal strips get the same charge and they repel each other.
you understood now? Because the
Yes.
same charge is traveling from the riffle, from this riffle to the mouth, to the inside the bell jar and to the strips. So all are positive, so obviously they will repel each other. That shows that the charge is transferred from the riffle to the metallic strips. Is it clear? This is called
Yes.
as electroscope. The whole unit or the device is known as electroscope. Any problem with that?
No, ma'am.
We'll do the revision of electroscope once again. Please go through it.
Electroscope. An electroscope is a device used to test whether an object is having electric charge or not. A
Ready?
simple
Do you follow that? Why are we using electroscope? To test whether the object is having electric charge or not. How can you see whether it is having electric charge or not? By the repulsion of the foil. Yes or no?
yes.
If it is straight, that means the electric charge is not flown. If it goes like this, then the electric charge is flowing through it. You got it?
Yes.
Next.
A simple electroscope can be made by using an empty bottle, a piece of cardboard, a paper clip, and two small strips of aluminum foil
Just a
past
moment.
one end of.
Just a moment. Now look over here. This is empty bottle. Agree? Yes.
Yes,
This is a cardboard which is on the mouth of the bottle. This is the paper clip, extended paper clip. Yes. And these two are aluminum foil. So all the things are included. Yes, beta. Hello. Girls, can you hear me?
yes, ma'am.
What I will do? Pass one end. Read.
Pass, pass one end of the paper clip through the cardboard and hang the two aluminum strips from the other end. If a charged body is touched to the end of the paper clip, the aluminum strips repel each other.
What I will do? Rather, what we will do? This paper clip is put inside the bottle, right? And to the U shape, we will put the aluminum foil. Yes or no? We will hang the aluminum foil, okay, on the paper clip. As soon as you get any object near the paper clip, this will move away from each other. The aluminum foil move away from each other, showing that it got the charges. You understood? The same charges rather. Any
Yes.
problem? Any problem, beta?
No, ma'am.
You can see over here. So this is aluminum foil. Otherwise, the aluminum foil was like this. Got it? But as soon as you get a charged body near the mouth of the bottle, this becomes like this. The aluminum foil goes away from each other, showing that it got charged. You understood?
Yes.
All of you understood better? Girls, are they there or they're gone?
Yes, ma'am, they are.
Now we'll see the story of lightning. Please continue.
The story of lightning. During the development of a thunderstorm, the air current moved upward while the water droplets moved downward.
Just a moment.
The
Just a moment. How does a cloud forms, beta? How does a cloud forms? You know that, right? The water vapor goes up, isn't it? With the dust
Yes.
particles and it forms cloud. So, water vapor is going up and the rain water is coming down. What do you say?
Yes.
Am I right?
Yes.
There's a friction. Is there a friction between the air and the water? There's a friction, isn't it? It is going up, it is coming down, again it is going up, again it is coming. So there's a friction. There's a rubbing of air and the water droplets. That causes the lightning. You understand? You understand better?
Yes, ma'am.
Now, carry on.
The vigorous movement cause separation of charges. By a process not yet completely understood, the positive charges collect near the upper edges of the clouds and the negative charges accumulate near the lower edges. There is accumulation of positive charges near the ground also. When the magnitude of the accumulated charges became become
Become.
very large, the air, which is normally a poor conductor of electricity, is no longer able to resist their flow. Negative and positive charges meet, producing streaks of
Streaks.
bright light and sound. We see streaks as lightning. The process is called an electric
Discharge.
discharge.
Now the scientists not have still able to understand why there's accumulation of certain charges on the upper edges of cloud and at the lower edges of cloud. They don't understand. No one is still able to define why it is happening. For example, at the upper edges, we get positive charges. What we get, beta? Positive charges.
Positive charge.
At the lower edges, we get negative charges. It is the cloud. I'm talking about the sky. Now we come to the ground. When we come to the ground, we have the positive charges. Now you got it's a sort of a sandwich. Now see over here. Got it? What it is? On the earth, it is positive. At the bottom, it is negative of the cloud. And on top of the cloud, it is positive. So you can see the sandwich positive, negative, and positive. You understood? In between, what is there? It is air. What is there better here? Air. It's
Air.
clear? Yeah. Now, what
Yes.
is air? Air is a poor conductor of electricity. Agree? Do you
Yes.
agree? Air is a poor conductor of electricity. Now, these lightnings cannot be withheld by the clouds, so it starts falling down. You understand? Because we know it is a poor conductor of electricity, so it starts falling down. Hope you have understood this much.
Yes.
So now the negative charge, this negative charge is meeting the positive charge, and that causes the lightning. What it causes? It causes
Light.
lightning when they meet each other. And these streaks are known as lightning. So you can see all these things are called as lightnings. You got it? Hope you have understood why lightning we see. Because
Yes.
because negative charges are meeting the positive charges on the earth and hence we see the lightning. Any problem?
No, ma'am.
Now some more information regarding it. Please
The process of electric discharge can occur between two or more clouds or between clouds and earth. Today we need not get frightened by lightning like our uh, ans-
read.
ances-
Ancestors.
ancestors did. Now we understand that basic phenomena. Scientists are trying hard to improve this understanding. However, lightning strike cloud destroy life and
It
property.
is good. It is not cloud.
Could a lightning strike could destroy life and property. It is therefore necessary to take measures to protect ourselves.
Fine. So this electric discharge, what we call as lightning, that can occur between two clouds. Okay? That can occur between two clouds. So when we say that clouds are coming close together, so we get this electric discharge or the lightning. Or there's an interaction between the clouds and the earth. Just now we saw, isn't it? Hello?
Yes, ma'am.
Hello? The interaction with clouds and earth, the charges in the cloud, the negative charge which comes close to the positive charge on earth, we get lightning. So we know about it. But some more to know is that when two clouds come close to each other, there is also electric discharge. Now, what ancestors were thinking earlier that the God is angry on us, so it is throwing light from the sky, isn't it? That is what they used to think, isn't it? Hello? See, you have to say
Yes,
yes or
ma'am.
no. Then only
Yes.
I understand that you understood. Okay. So now scientists are researching on it to find out the exact reason. This lightning can cause destruction. It can kill people. It can destroy property. I told you the building can be on fire by lightning. People can be killed by lightning. Okay? So we have to take certain preventive measures, certain safety measures so as to reduce the destruction. Now we see what are the types of lightning. Please read.
Types of lightning. There are three primary types of lightning from a cloud to itself, intracloud or IC, from one cloud to another cloud, CC, and between a cloud and the ground, CG. Although lightning is always accompanied by the sound of thunder, distant lightning by may be seen but may be too far away for the thunder to be heard.
Okay, fine. Now I will just show you what are the types of lightning. Now if it is a cloud, right? This is a cloud. Inside the cloud, it is lightning. This is icy. You understood? Hello? Is it
Yes, ma'am.
understandable? Okay. Now, this is one cloud. Now, this is one cloud, and we are taking another cloud. Excuse me. This is CC. Then the both thing becomes CC. You understood? Two clouds, so it becomes CC. You understood or not?
Yes,
Yes? Now we will take the cloud is plus over here, it is minus over here, and the earth. What is earth beta? Positive. Is it clear? And the interaction, the lightning which is falling. This is CG. What it is beta? What is it? CG.
see,
Understood?
yes,
See over here. See, this is positive, this is negative, and this is positive.
positive
And when negative comes down, it comes as lightning.
lightning, yes,
Okay? Because negative is coming towards positive. Any problem?
yes.
Now, how to have safety measures in what form? We will see. Please read.
Lightning conductor. A lightning conductor is a device used to protect buildings from damage due to lightning. A lightning conductor has a metallic rod. The upper end is pointed and the lower end is joined to a metal plate buried inside the ground. When lightning strikes, the electric charges pass through it to the earth without causing any damage to the building.
What is lightning conductor? Can you see this? This is a building. So this is a building. Okay, this is a house. And here a pointed rod is the lightning rod. Can you see this one? This is the lightning conductor. You understood? This is the lightning conductor. All of you agree?
Yes.
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 So this has got a pointed tip, and whenever there's a flash of lightning, so you can see this is lightning, flash of lightning, it is taken by the lightning rod. This much you understood better?
Yes,
Yes.
ma'am.
It is giving protection to the building, okay? And there's no further cause of damage. What is lightning conductor, by the way? It is a metallic rod. It is a metallic rod. And the upper end is always pointed, and this lower end is joined to a metal plate which is buried inside the ground. See, I will show you. Here it is connected, it's cabled. Can you see this? It is going down and is inside the earth. You got it? It is inside the earth. Can you see this over here? See, this is the grounded. Okay? So the whole electricity has come down. It has become earth. Earthing. This is called as earthing. You understand now? Hello,
Yes.
girls.
Yes, ma'am.
So what happens whenever there's a lightning? See, you can see this. There's a lightning over here. So the electric charge is passing through the lightning rod to this cable, isn't it? Isn't it better? And it goes straight from this copper cable. It goes straight to the ground where all the energy is absorbed. So my house is saved. There's no destruction to the house. What do you say? Hello, girls. What do you
Yes,
say,
ma'am.
Peter? Now, how do we protect ourselves from lightning and thunderstorm if you're outside the house, if you're outdoor? Let's see one by one. Yes, better.
Open vehicles like motorbikes, trucks, open cars are not safe. Open field parks,
Elevated.
places,
Better vehicle.
elevated places, tall trees are not safe. Carrying an umbrella is not safe. If in a forest, take shelter under short trees. If in an open field, stay away from trees, poles, metallic objects. Do not lie down. Squat on the ground with hands on the knees and the head between the hands.
So if you're outside and, for example, suddenly you get the thunderstorm or lightning, what you will do? So generally, if you are on open vehicles, for example, motorbikes, trucks, open cars, don't travel. It is not safe. So lightning may occur. And if you're in open fields, parks, elevated places like sort of a small hill areas, tall trees, they are not safe because likelihood of lightning is more on these areas. Also, do not carry an umbrella because you know that umbrella has a metallic rod, isn't it? Umbrella has a metallic rod. Hello, the lightning can fall on your umbrella. Is it clear? Because it will attract. So, and you may die. Like we will be electrocuted. If at all you are stuck in a forest, don't take shelter under tall trees because tall trees can take more of current. They can attract the lightning as compared to the short trees. You understand? And if at all the tall trees, obviously if it falls, we may die. Short trees, if it falls, there's a chance of survival. And if you're in an open field, try to be away from trees because we know that when lightning falls on trees, the trees at times burns or it can be cut into two pieces. We know all these incidences. Also, the poles, the electric poles, be away from the electric poles. Be away from, you should not have any metallic objects in your hand because may have the chances of lightning. Also, do not lie down, but instead you should squat on your haunches with hands on the knees. Keep your hands on the knees and your head should be between your hands. This is the way you should sit down whenever there is a lightning. And when you're inside the house, what you should do? Let's see. Please.
Inside the house, lightning can strike electric wires, telephone cords, and metal pipes, so contact with these objects should be avoided. It is safer to use mobile and cordless phones than wired phones. Electrical appliances like TV, computers, etc. should be
Unplugged.
unplugged.
Bathing.
What
Bathing
Wading should be avoided to avoid contact
with running water.
with running water.
Now, if you're inside the house, what you should do and what you should not do. Now, we know that the lightning can hit the electric wires, the telephone cords, and metal pipes. We know that because the lightning will always come to metals. It will be attracted by metals. So, you should not touch all these things at home. You may be electrocuted, or we may get an electric shock. Secondly, it's better instead of using telephone cords, instead of using telephone, which are using telephone cords, switch over to mobile phones or cordless phones. You understand? That is better. That is safer. Also, electrical appliances at home like TV, computers, it should be you should remove the plug because they may be short circuit. Also, don't ever try to take bath whenever there is lightning or thunderstorm. Why? Because running water, remember the water which is running from the tap is metal. Hope you know that tap is metal. And the running water is a good conductor of electricity. You know that. While taking bath, we will be electrocuted. We can get the electric shock while taking bath. Hope you understood. So all
Yes.
these things you should not be doing whenever there is lightning or thunderstorm. If shelter is not available, this is the only way to be safe. See, I told you, you have to be squatting on the ground and put your hands on the knees and your head in between your hands, isn't it? Just now we taught. Yes? Okay, now we are through the lightning and the thunderstorm. Now we come to the second natural phenomena that is earthquakes. Please start to read.
An earthquake is a sudden shaking or trembling of the earth caused by a disturbance deep inside the earth's crust. Earthquakes cause damage to buildings, dams, ditches. It can cause landslides, floods, and tsunamis. It can also cause damage to life and property.
Now, what is an earthquake? All of a sudden, you feel the shaking or the trembling of the earth. All of a sudden. Why it is happening? Because there's a disturbance inside the earth. Okay? We are living on the crust. Inside it is mantle. Inside the earth it is mantle. So there's some disturbance in the mantle which is coming or which is observed, which is felt by all of us in the form of earthquake. Now, earthquake caused lots of damage to buildings, dams, bridges. Also, it can develop landslides. You know what are landslides? For example, there are mountains or there are hills on the either side of the road, and due to earthquake, the rocks and the soil or the earth will start falling, and it will cover the road, it will just block your road. This is called as landslide. That means a piece of land will start sliding and it can uh, create obstruction to the traffic. Is it clear? That is called as landslide. Floods, you know that. Why does flood happens? Can anyone tell me? What exactly is flood, beta? Girls, do you hear me? Hello, girls. Hello.
Yes, ma'am.
Yes. What is
Yes, ma'am.
flood, beta? What is flood?
Overflow of water.
Overflow of water. Okay. That means river is flowing. And if the river changes its flow, that means if the river changes its path, then also we get flood. You agree? If there's
Yes.
more water in river, then also we get flood. Yes? So there are
Yes.
two ways of flood. One, that it changes its direction. If the river changes its direction, we get flood. Yes or no? And if the water, the capacity increases in the river, then also we get flood. Any problem? Yes? And what are tsunamis? Girls, what are tsunamis, beta? This is the earthquake under the ocean. What is tsunami, beta? Hello? Hello?
Tsunamis is that the overflow of sea.
Yeah, it is the earthquake under the ocean. Got it? So you are getting earthquake under the ocean. That creates tsunami. Now look over here. This is one. This is earthquake, right? See, can you see this better? This is another. See, the road is broken. Yes, and this is tsunami. Can you see this? This is tsunami. Understood? Hello? You got it? This is tsunami.
Yes, ma'am.
Now see how tsunamis take place. This one was actually here, but due to the fault line actually generates the earthquake. It has gone up. You agree? Yes, beta? Otherwise it was like here,
Yes, ma'am.
but it has gone up. Now it has gone
Mm.
up by this much, isn't it? So you can see over here, it has gone up by this much. Agree? This much it has gone up. All of you agree or not, beta? So how many plates are working? This is one plate and this is second plate. What is happening? This plate is pushing the second plate, and somewhere over here it causes the tremors. Now this is the epicenter of the earthquake. You understood? The earthquake generated over here, but it is felt somewhere else. This much have you understood? Now what happens? The water above this area, see, the water above this area, what happened? It goes straight, it went up. Is it clear?
Yes.
And a wave is created. What is created, beta? A wave is created. A huge wave is created. That is called a tsunami. Any problem?
Okay. No, ma'am.
This is called tsunami, and this is what you see. These are the waves. Huge waves are created in the ocean. That is tsunami. Any problem?
No, ma'am.
Now we see what exactly caused an earthquake. Please begin.
Okay, ma'am. What causes an earthquake? The outermost layer of the earth called crust, it is not a one piece, it is a fragment. Into many
Properly. Tanzil,
planets, this
Tanzil, is it you, Tanzil?
hello. Yes, ma'am.
Yeah, read properly, please. The meaning is lost. If you keep a break in between the sentences, the meaning is gone. So
Okay,
please continue with the sentence.
these planets are moving continuous within
Hello, these are
this
not planets,
plates.
beta. These are plates. You have to read properly.
Yes.
Okay.
Delisa, please continue. I don't have much time. I got just 2 minutes. Delisa, continue, beta. Delisa, can you hear me? Can anyone else read? Hello? Delisha, is there anyone? Girls, can you hear me?
Hello.
Yes. Is anyone there? Hello? Hello? Girls, can you hear me?
Hello, ma'am.
Yes. Where are you?
Yes, ma'am.
Yeah.
Ma'am, I was
Continue.
going to washroom.
Yeah. Okay. Continue.
What caused an earthquake? The outermost layer of the earth can called
Call.
crust is not one piece. It is fragmented into many plates. These plates are moving continuously. When these plates brush past each other or when one plate goes under another plate due to collision, they cause disturbance and causes